Hi, my name is Chris Freeman. This is a review for my students for AP Environmental Science, getting ready for their big exam. So I want to talk to y'all about the rock cycle a little bit. We were just starting to get into different rock types here. So where we left off was identifying there's two important rocks for sedimentary rocks that you should try and remember. One is limestone, and limestone is important because it's made of shells, and shells are made of calcium carbonate. And calcium carbonate's a very important thing to remember for the AP Environmental exam, because if you have acidified soils or if you had an acidified small lake or pond, you could put pulverized, crushed calcium carbonate, crushed limestone, crushed shells into the lake, onto the soil, and that can change the acidity and neutralize the acidity, which is important to be aware of. Okay, and so limestone is a great example of that. And limestone, if it gets squished and mushed enough, will actually become a metamorphic rock known as marble. So that gets back to this rock cycle here. You can take sedimentary rocks and they can be squished and mushed under heat and pressure, and they can morph into something like limestone, going and becoming marble in metamorphic rocks. So let's also talk about coal and the different stages of coal. That's very, very important as well. So before we get coal, we have some sort of biological thing, and that would be peat. Not some guy that you know named Pete, but a peat bog or swamp. And this organic material, if squished enough, can become lignite, and that's important to know. It's a very weak sedimentary rock, not very compressed tightly. It'd be closer to the surface. And then if you squish that a little bit more, you can get subbituminous. And then you can squish that a little bit more and you can get bituminous. And bituminous has a lot of impurities, a lot of sulfur dioxide that's burning, a lot of mercury, a lot of arsenic, a lot of bad things, but it provides a lot of energy. And that is a very compressed sedimentary rock. If we went any further, there's one other type of coal that actually breaks out of sedimentary and is then metamorphic, and that's anthracite. And anthracite gets squished so much that it becomes metamorphic, and a lot of the impurities get pushed out of it. It's a fairly clean burning coal. It does release a lot of carbon dioxide, but it burns hot, burns clean, but it's deeper down, so you have to have a shaft mine to get to it instead of a mountaintop removal method of extraction. So there's a little more danger involved in that. It's more expensive, and we just don't have as much anthracite in the United States, where coal is very, very abundant overall, and bituminous, we have a lot of that, more than any other country in terms of coal there. So we have some sedimentary rocks that are worth knowing about because of how we use them and how they can help us out environmentally. And so since I was talking about metamorphic rocks also, it's important to know marble for the same reasons that I was talking about, also because it can dissolve. These beautiful marble statues, marble banks, whatever it might be, the Arlington cemeteries, they could potentially dissolve with acid rain. And so that would be a problem as well. Just as limestone with acid rain would dissolve, we have a metamorphic rock that would dissolve as well. Okay, and then slate is just shale that has been compressed and morphed into a metamorphic rock that's harder. We use that for building materials, so that's also important to know about. So those are two metamorphic rock examples that might be worth noting, but oftentimes the big ones, if you're going to memorize some rocks, it'd be limestone and coal to help think through writing some stuff down on some of your FRQs. Now, igneous rocks, we have basalt. That's going to be oceanic crust. And then we have granite. And granite is going to be our continental crust. So our continental crust is less dense than our oceanic crust. So granite is about 2.7 grams per cubic centimeter, and basalt is about 3 grams per cubic centimeter. So just be aware that basalt is more thin, more dense. It's going to subduct and get pushed down underneath our granite, which is our land-based crust. So there you have it. There's some more information. Let's dive right into soils. We have the O horizon. That's going to be the organic layer of thick leaves or pine needles. Tends to be acidic. So it's going to have some acids with water. It's going to acidify our soils slightly, particularly if you have pine needles there. But it also is something that we have to worry about with forest fires, right? If you have a thick O horizon, the humus is going to catch fire and really wreak havoc on a forest. So we can think about integrated management, fire management for our O horizon, and maybe do some prescribed burns. We can remove some of the small trees and dead limbs that would catch fire in drier areas. Then we have our A horizon that is going to have some minerals and a lot of broken up tiny organic matter. It's going to be rich, dark, and black. And the A and the E horizon together are the zone of leaching or alluviation. This is where water trickles down through, takes some of the clay particles, some of the minerals, and brings that to the B horizon that has quite a lot of clay, a lot of different color. The E horizon you see here is a lighter color because a lot of the minerals have been pulled out of it. A lot of the clays have been pulled out of it and deposited in the B horizon. And then we go to the C horizon that has a lot of parent material in that. That's important to know. The R horizon is bedrock. So you should know these in order. You should know some of their relevance. You don't always have to have all the soil horizons present, but nonetheless important to be aware of. So parent material is where all mineral rock comes from. Then you have daughter material as that material gets broken down and broken apart. So there you have it. B horizon is where you have accumulation of all the leaching from A and E. So that's important to know your soil horizon. You can try and make up some soil song. O, A, E, B, C, and R. Now I know my soil horizons. Why am I singing that? It doesn't even rhyme. Okay, let's move on. Now let's talk about soil texture and think about the importance of that. If you're a farmer, you want a nice loam that's going to drain but still hold some amount of water. And a loam is going to be 40% silt, 40% sand, but it's going to only have 20% clay. And there's some variation in loam, but if you remember 40, 40, 20, and the 20% is clay, that's going to be a really ideal growing conditions for most farming practices. And you can certainly have more clay-based soil. We have a lot of clay-based soil in Virginia Beach. If you have more clay in your soil, you want to water less, or you want to add more organic matter to try and make a little bit more percolation and water flow, make it more permeable. So this has to do with texture. So this is the soil texture triangle. And so we want to think about these 3 textures as the sizes. Remember, we did this test where we did the ribbon test, and we dug down and we examined our soil profile, and we found that we had a lot of clay in our soil. So that is the ribbon test, the soil texture test. It's a field-based test that you can quickly analyze soil, and that's a physical test. Now, we could have done a chemical test and used looked at the pH of our soil to decide how acidic or base our soil is, and that would give us an understanding of if we needed to add calcium carbonate, broken up pulverized limestone, or pulverized shell fragments onto our soil to help adjust the pH and neutralize its acidity. So these are things that we can think about, we can work through and analyze. You can also look at the color of clay. If you have or the color of soil, if you have gray soil, that tends to mean that the iron, that it's been under waterlogged for at least part of the season, and that it's a very wet soil where you have anaerobic digestion and ferric iron is getting gobbled up. So that's an important thing to sort of think about. You can do a color analysis of your soil as well. All right, that wraps up our talk.